everybody, welcome back boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, we're working on that Unit 7 practice test for that wonderful competency, and we're trying to figure out, mainly switching back and forth between those polynomial equations, meaning a multi-term equation, and switching between those and a graph. What do they look like? What are some of those key features, and how can we find them? So for number one, it says determine the polynomial equation for a graph that passes through the point 0, 15 and has three x-intercepts at -5, 0, -3, 0, and 2, 0. Show all your work, which is always what we do. So what you want to find is have that general form. So we're going to say the general form is going to look like this. We're going to say our function f of x is going to have multiple terms. So we're going to say a times x minus b times x minus c times x minus d, so on and so forth, where these sets of parentheses are going to be those x-intercepts. I put minus because we have to take the opposite of that value. So whatever point it goes through in your graph, it should be the opposite of that point in your equation. So what we're going to do is we're going to say, well, I can kind of start this out. I can say, well, my function, I'm going to say f of x equals a, because we don't know what that is yet, and we're going to solve for that. But what we can do is say, well, the opposite of -5 is +5, so we're going to say x plus 5. We're going to say times x plus 3, because opposite of -3 is +3, and the same idea with, since we have 2, we're going to say minus 2. So just make sure you're taking the opposite of those x-intercepts. And now we have to solve for a. So solve for a. And how do we do that? Well, notice how I didn't use this other point of 0, 15. And so what we're going to do is we're going to say, well, instead of x, we're going to put a 0, and instead of a y, we're going to put 15. And so I can rewrite our equation just like that. So I'm going to say I have 15 equals, I have a times 0 plus 5, I have times 0 plus 3, and times 0 minus 2. And so what we did was we have to use this extra point to solve for a. So I'm going to say solve for a by using other point. And you substitute those values in for your variables, and you're going to solve for a. So I'm going to say, well, I can simplify. This is going to be 15 equals a times 5 times 3 times -2. Make sure you can multiply. So when I have these three values multiplied together, again, I can also pull up Desmos if you want to type it in exactly as it looks. So let me show you what that looks like. There it is. Okay, so let's do, so if I wanted to, I could type it in exactly as it looked. So I had 0 plus 5 times 0 plus 3 times 0 minus 2. So if you type it in exactly as it looks, you'll get your answer that you're looking for. So we're going to say that's going to be -30. So I'm going to say I have 15 equals a times -30. And make sure you're reminding yourself how those steps for solving equations work. And real simple, one-step equation, divide both sides by -30 to get a by itself. Again, you can leave it as a fraction if you'd prefer, but what we're going to do is this. I'm going to say, let's do back to green. I'm going to say a equals, I'm going to say -1/2 if I want to reduce that fraction, or if I want to write it as a decimal, that's also totally fine. I would say -0.5. And be careful here because a lot of people are going to say, hey, this is my answer, and they're going to box it in. Notice how it always reread the question. It says determine a polynomial equation. So I need to have this form of my equation. So what I'm going to do is I'm going to take and say, all right, I'm going to take that answer that I found for A, and I'm going to rewrite it into our original equation. So rewrite, if I can undo, there we go. Oh, too far. So rewrite original equation. Instead of A, we now have negative 0.5. So I'm going to say, let's have f of x be equal to negative 0.5 times x plus 5 times x plus 3 times x minus 2. Box in that answer so that way you know what to look for. Make sure you also know I can always check, so check by graphing. So what I'm going to do is I'm going to type in this full equation exactly as it looks. So let's go back to our wonderful Desmos calculator, and so I'm going to say let's have f of x. I'm going to say it'd be equal to, we got negative 0.5 times x plus 5 times x plus 3 times x minus 2. Let's get this crazy looking function, but what information do we know? Well, we know it has to pass through a couple points. And so what you can do is you can check and see, well, it passes through that y-intercept of 0, 15. It passes through the x-intercepts of negative 5, negative 3, and positive 2. So as long as it passes through all points, you know it is correct. So make sure you're checking by graphing. All right. On the next one, it says study the graph of f of x. So it has like a couple curves to it, a W shape. And it says how many real and complex roots does it have? So first up is what we're going to do. We're going to count the number of changing points. So if I look at that, again, points of inflection, where it goes from increasing to decreasing and vice versa, that's where we're going to count a changing point. So I'm going to say, well, I'm going to have, say we have one point here, we have another point here, and we're going to say anytime we have that changing point is a point of inflection. So you're going to say, as you trace along your function, you're going to say, all right, well, I have 1, 2, 3 points of inflection, or 3 changing points. I'm going to say 3 changing points. And why do we do this? Well, because when we go to find our degree, we're going to say our degree is going to be equal to changing points, so number of changing points plus 1. So if we look at that, we're going to say 3 plus 1 equals 4. That's helpful because we also know that the number of roots is equal to our degree. So we're going to say our total number of roots is equal to our degree. And so we're going to say, well, since our degree is 4, our number of roots is also going to be 4. And so we can kind of narrow it down. So now what I want you to do is first say, okay, well, I know I have 4 total roots for this function. And we're going to say, since our degree is 4, and so then we're going to say that's in between, we're going to count, so count x-intercepts. So we're going to first count x-intercepts for real roots, So I have 1, 2. So since I have 2 x-intercepts, I have 2 real roots. Then I could say, well, from that, I know that I have the number of remaining roots is going to be equal to our complex roots. So number of remaining roots are complex. So I'm going to say we have 2 complex roots. So that's kind of that step-by-step of how you find those changing points and find your degree, find how many roots you have. Again, we don't have the equation, but that's okay because you usually want to make sure you can use that as much as possible. But what we can do is we can say, break down piece by piece. Also too, as soon as you find your number of changing points, I can cancel out some of these answers because I said, well, my degree is 4, which means my number of roots is 4. So I could cancel out B and D because those, so this is too many, this is not enough. And what I can say from A and C, we can say, well, I know I don't have 4 real roots because I do not have some only 2 x-intercepts. So since there's only 2 x-intercepts, we know that C is wrong, which means the only choice left is A. Alrighty. On number 3, it says study the following polynomial equation or function. So that goes f of x is equal to 0.4 times x plus 4 times x plus 7. So what I want you to do is pause and graph on Desmos first. So pause the video, make sure you can graph on Desmos. We'll talk about that equation here in a second. All right, so now that you have it graphed out in Desmos, let's take a look. So it looks something like this. So notice how it has, some different curves to it. Let's talk about polynomials. So we're going to have, something that has more than just, a U or an N shape because those are just quadratics. So our degree is going to be more than 2. So what else do we have? Well, some key parts to this that I notice and say, hey, I have some x-intercepts at these points. And I could also say that point 0, 0 is also our y-intercept. And so what I would do first is kind of sketch that out. And so it's almost like we're doing this problem in reverse just because it's a little bit easier to do. So what I'm going to do, I'm not going to have a perfect picture, but what I'm going to do is kind of sketch that out first. So let's do that. So we hide this again, and let's sketch it out. So now let's do the sketch. So we had x-intercepts on, it was -4, it was -3.5, and it was 0, 0. So again, your picture's not going to be perfect, but that's okay. We said that it went down to the left, it went up to the right, and kind of has that Z curve to it. I think it kind of went down past 6, and then back up, something like that. Again, it's not gonna be perfect, but it's gonna be we can call this a rough sketch. What you do need though is you have to be able to label those intercepts. And so I'm going to say I have an x-intercept right here, I have an x-intercept right here, this is also an x-intercept, and this is also a y-intercept. So just make sure that you're plotting those 3 points down first, and then make sure you label. All right, so part B is done, but we need to identify some key features. So let's do just that. We said we have x-intercepts, and we're going to say at x equals -4, -3.5, and 0. Then we could say we have y-intercepts, intercept singular, at y equals 0. So again, x-intercept is where y is equal to 0, y-intercept is where x is equal to 0. So make sure you're careful on this as well. All right, what else do we need? We have key features include x and y-intercepts, end behavior, which we need the leading coefficient. So again, anytime you see that vertical stretch or shrink, just think leading coefficient, which is a. And then we also need the degree. So we're going to say, let's say, leading coefficient. What's that value at the front? So leading coefficient. So we're going to say, let me put the colon there. We're going to say A is equal to that front value right there. We're going to say A is equal to 0.4, which is also positive. Then we talk about the degree. Well, how many x's do I see? How many sets of x's do I see in my equation? I have 3 x's, and that makes sense because if I look at my curve, how many changing points do I have on my curve? I only have 2 changing points, which means my degree is going to be 3. So I'm going to say degree is going to be 3, which tells me it is odd. Make sure you use the end behavior chart, or you can also look at your picture, but I can say my end behavior. Oh, sorry, let me also, if I'm talking about vertical stretch and shrink, I would say this is also, since it's between 0 and 1, it's going to be a stretch. It's a stretch because, as you have your values get closer to 0, it should be expanding. So then we say, end behavior. Well, what do we have? As we move to the left, so as x goes to negative infinity, what happens to y? Well, our y values go down, so we're going to say y also goes to negative infinity. Then if we have, if we move to the right, as x goes to positive infinity, what happens to our y values? They go up. So make sure you can kind of use that end behavior table to kind of fill out and figure out what you need, but those are going to be your key features that you need for this problem. On number 4, it says in the xy plane, the graph of the function f of x has zeros at -7, -3, and +3. Which of the following could define f of x? So similar, or I say similar to the problem number 1, but what we're going to do is we're going to take opposites of points for that general equation. So if I look at it, I'm saying, okay, if I look at these zeros, again, anytime I have zeros, I'm talking about solutions. I'm talking about, I could say solutions. I could say roots. I could say x-intercepts. So make sure that you have those 4 words are interchangeable. They all mean the same thing. It's where your graph hits the x-axis. It's where y equals 0. So for each of those points, so I'm saying I have -7, 0. I have -3, 0, and I have +3, 0. And so what I want you to do is I want you to write that general equation. Notice how each of those choices has your function. We're going to say a, for this case, a is going to be equal to 1, since that's the case for each of those equations. And we're going to say, well, take the opposites of these points. Well, I have to say I'm going going to say x plus 7. I'm going to have x plus 3, and I have to have x minus 3. So again, make sure you're careful, have the opposites of each of those roots, each of those x-intercepts. Another way you could do it is if you want to, anytime you have the equation, make sure you can graph. Anytime you have that equation, make sure you can graph, but we're going to say it is going to be choice C. So I had to find it in there. Again, we said A is wrong because of this choice, and B and D are wrong because of that x minus 3 squared. So make sure you're putting and saying that your choice is C. And for number 5, it says study the graph. I have a couple curves. And what you can do is say which of the following could be the equation for the graph above. So a couple strategies. So let's say strategy 1, find key features and get equation, or strategy 2, graph each equation in Desmos and compare. So either of these will work, either of these will give you the correct answer, but I'm going to show you, I'll show you either way. Make sure you can ask if you want both, but let's say this. What I would say before anything, you definitely want to, if you do strategy 1, you definitely want to check your equation using Desmos. To get the same picture, what I suggest you do is you change your windows. So let me pull up our Desmos window, and let me clear that out. All right, so again, anytime you move your window around, click that little home button, so that way it has default zoom. In our problem, we had, let me unhighlight this again. In our problem, kind of see where we have. So our x-axis goes from -6 to +4, and it counts by ones. So let's do that first. So we said, so click the little wrench in the top, x-axis from -6 to +4, count by ones. Let me double check. Yep, and then our y-axis goes from 20 to -40, and it counts by 5. So let's go from -40 to 20, and count by 5. So make sure you can get comfortable, using your Desmos calculator. Change that window so that way you can make sure your graph is exactly what you need. All right, so now let's do it like this. I'm going to say, if I have key features, let's find some changing points. So I'm going to say, well, I have traced along my function. I have 1, 2, 3 changing points. Let me write that down. So I have 3 changing points, and that means my degree is equal to 4. So right away, let's see what choices I can eliminate using that idea. Well, I could say I have, I know it can't be A because that degree is 3. And the other ones, I have 1, 2, 3, 4. Other ones are good. So I can cross out knowing that information. What else do I have? Well, I have, when I'm talking about my roots, I have a root at, so this is going to be x plus 5, I have x plus 0, or just, x. It's just x. And this is going to be x minus 3. So when I'm looking at my equation, I also have to say, hey, this is a double root. So I'm going to have x squared in the front, so I can cross out a choice C because I know it can't be that one. What else do I have? Well, I have that x minus 3, x plus 5, and so I know I can cancel out D as well. So real simple. I was able to kind of find that it's going to be B, but I always double check using Desmo. So I'm going to type in this equation exactly as it looks. So let's pull up Desmos again. So I have f of x equals, get that function back. It says 1/3 times x squared, x squared, and then x minus 3, x plus 5. So what do we got? Well, what kind of points does it go through? It has the point -5, 0, has a double root on 0, 0, and it has that point of 3, 0. So again, make sure you can kind of check and see if those are right. That way you can see what they should look like. So I'm going to actually unhighlight. Let me prove that the other ones are incorrect. So let me look at this first one. It says y equals 1/5 times x times, switch back and forth, x plus 3, x minus 5. So yeah, notice how, like, I didn't change the window. This is just exactly what it has. So notice how, just this picture is completely incorrect, so I know it can't be that one. Let's look at the next one, that choice C. So we have y equals 1/10 times x squared, or sorry, just x, x minus 3, or sorry, x plus 3 squared, x plus 3 squared, and is it x minus 5? Yeah. So looking at this picture, again, this is the strategy 2 where I'm just plugging in those equations, seeing if they work. This one obviously doesn't work either. And let's look at that third choice. So we have, this is similar to this one. We had x squared, we had plus 5, sorry, plus 3 minus 5. Yeah. So again, same idea. Notice how my roots are incorrect because I need to have a root on -5 and I need to have a root on +3. So I know that this one is incorrect too. So again, if you wanted to use that strategy too, where you graphed each of those out, you'd be able to say, hey, I know that these are incorrect, but I know that this one is correct because it's the only one that matches the picture given. So make sure you can use either strategy for yourself. You can be sure to pause, rewind, replay as needed. Make sure you can ask questions as they come up. And as always, super slam that subscribe button.